Hello all, today we are going to start with our next chapter, that is Introduction to Friction. The theory part of this chapter I already provided you, so I suggest you before watching this video you once go through the notes so that you can easily understand this chapter, that is friction. So in the friction chapter there are basic terms like the definition of friction, then classification of friction, coefficient of static and kinematic friction, angle of friction and angle of reverse. And after completing this theory part we will see the problems based on block friction and ladder friction. So start with our chapter. We will see the basics of friction. Okay, now we will take one table, or you can take any surface. Suppose this is a table. Now at the first sight, when you look at the top of the table, that is the surface of the table, it looks like it's very smooth. But when we observe this table under any microscope, if you observe this part, so you can find some irregularities. That is, so sir, there are some roughness, that is irregularities on the table surface. Same way, if you take any block, okay, same case is applicable for this block. So though this block is look like a smooth surface, if you observe any part of this surface of this block, so you can find some irregularities on this block. Okay, now what I will do, I will place this block onto the table. I will place this block on this table. As we know, if you observe under microscope, so we can find some irregularities on this surface as we are seeing here. Okay, now due to this irregular surface, so what happens, there will be a interlocking between these two surfaces due to this irregularities. The irregularities may not be like this, it will be of any shape, but as we place this block onto the table, so there will be interlocking between these two surfaces. Okay, now I will draw here. Now when we will start to move this block in this direction, okay, so this is force P. Now what happened when we start to move this block in this direction? So due to this interlocking property, this surface, okay, so this interlocking will oppose this motion. We are moving in this direction, so this interlocking will oppose this motion. Okay, so our opposing direction will be this. So this opposing motion, this opposing motion is called as friction. Okay, so based on this theory, so what is the definition of friction? Okay, so definition of friction is, it is defined as the resistive force acting in opposite direction in which it tends to move or it moves. Okay, so once again we will repeat. So this is a block, this is the table, the block is placed on the table, we are moving this block in this direction. Okay, but due to the interlocking between these two surfaces, so this interlocking will opposite this motion. Okay, and that opposite force is known as friction. Okay, it is also called as force of friction, or simply we can call it as a friction. Now the next part is the classification of friction. So there are basically two types of friction. So first is static and second is dynamic. So what is the difference between static friction and dynamic friction. Now we will take same example. This is a block which is placed on a table and we are applying the force in this direction. Okay, now though we apply the force P in this direction, this block is not moving, it is at rest. So it is the friction experienced by a body when it is at rest under the action of force. That is meant by static friction. Okay, so we are applying the force to this body, to this block. So though we are applying the force, it is not moving, so it is experience the friction. So that friction is not static friction. So basically the static friction is frictions experienced by a body when it is at rest. And what is dynamic friction? This is a block placed on a table. We are moving this, we are applying force to this block in this direction, and this block is moving in this direction. Okay, and when the block is moving, so that time whatever the friction experienced by this block, that is known as dynamic friction. Again, there are two types of dynamic friction. First one is sliding friction and second one is a rolling friction. So what is sliding friction? This block is placed on a table and as we apply the force in this direction, so it will slide onto this table. Okay, so that is called as sliding friction. So the friction experienced by a body when it slides onto this table, onto the surface, that friction is known as sliding friction. And now what is rolling friction? So if we take the example of roller or cylinder, when the cylinder is placed on this and when it moves in this direction, so it will experience the friction, and that friction is known as rolling friction because it rolls, and that friction is known as rolling friction. Now the next concept is limiting friction. So if you remember the concept of static friction, just now we have discussed about static friction. So what is static friction? So it is the friction experienced by a body when it is at rest after applying the external force. So in the static friction, though we apply the force to this block, so it is not moving. Okay, and the friction experienced at that condition is known as static friction. So similar to the static friction, we will see the concept of limiting friction. So what is limiting friction? Now let's suppose I am applying a 10 Newton of force to this block. So though I am applying 10 Newton of force to this block, it is not moving. So due to this static friction, or due to this frictional force, so I increase the force by 1 Newton, 11 Newton. So though I increase the force up to 11 Newton, it is not moving. I am taking these values for just example. Okay, so I am increasing the force. Though I am increasing the force, so this block is not moving. So what is happening at this? So this opposing force, that is frictional force, is increasing its magnitude so that this block doesn't move. Okay, again I am increasing the force, suppose 15 Newton. Though it is 15 Newton, due to this frictional force, opposite force, okay, it is not moving. Why it is not moving? Because this frictional force value is increasing as we are applying the force, or as we are increasing the force. But there is a limit to this frictional force. Okay, and if you cross this limit of frictional force, so this block will start to move. Okay, so when this block will start to move, when this applied friction value is, applied force value is to this frictional value, that is F max. When this P will reach to the maximum value of frictional force, then this block will start to move. Okay, so this maximum value of frictional force, okay, when a body just start to move, okay, or will just slide over the surface, okay, so that frictional force is known as limiting friction, okay, and that motion is known as impending motion. Okay, so what is happening in this? Though we are increasing the force, this block is not moving. Why? Because this frictional force has a capability, one property, that it adjusts its magnitude when we increase the force, but this frictional force has limit. Okay, so that limit is F max. When we cross this limit, so this block will start to move in this direction, means in the direction where the force is applied. Okay, so this maximum value of force when the body start to move is known as limiting friction. Okay, and when the body just start to move, that motion is known as impending motion. Okay, now this concept we can represent with the graph. Okay, now you can express this concept in your day-to-day life. Okay, so whenever we pull any heavy object, okay, when you want to move any object, heavy object, so at the start we need a large force. Okay, means what? If you try to visualize this concept, okay, suppose this is a force which we are applying on the x-axis, and this is the frictional force. Okay, frictional force. Okay, so as we start to increase the force, the frictional force is also increasing. Okay, as it's having capability that it adjusts its magnitude. So as we start, as we increase the force, the friction increases. Okay, but as we have seen, there is a limit to the friction force, so that limit is known as F max. So here is the limit. So up to this limit, your part or block will not move, that is no motion up to this force. Okay, but if you cross this limit of F max, so what will happen? The body will start to move. Okay, but at that point, so this frictional force will suddenly drop to some value. Okay, and the body will start to move. Okay, after that, when we move, the frictional force remains constant. Okay, so you can express this in your day-to-day life. Okay, when you move this block at the start, we need an extra force. Okay, but when we start to move, then you can feel that we require less force to move this. Okay, so that less force due to this. Okay, when you start to move, the frictional force suddenly drops and then remains constant. Now the next concept is normal reaction. So for this concept, we will take two examples. A block is resting on the table and the block is resting on the inclined plane. So consider these two conditions are in equilibrium. Means what? So this block is in equilibrium, it is not moving. Okay, now when such a situation is there, okay, so its weight, the weight of block will act vertically downward through its center of gravity. It's act vertically downward through the center of gravity. Okay, as we know, every action there is a equal and opposite reaction. So as the weight of block is acting vertically downward, the plane, this plane, okay, or surface, in turn exerts an upward reaction on the body, exerts an upward reaction to this body, like this. And this upward reaction is perpendicular to the surface. Okay, if you redraw this, so its weight is acting downward, okay, and perpendicular to the surface. Okay, so there will be a reaction. Okay, same here for the inclined surface. So its weight is acting vertically downward and perpendicular to this surface. There is a reaction. Okay, so the reaction which is acting perpendicular to this plane, okay, is known as normal reaction, and this is generally denoted by N or R.